Hello. In this video, I'll go over this soccer object detection package. It's a fairly small package, so it shouldn't take too long. So here inside this package, we have a source folder. If you go inside here, there are two functions that are important in this package. Object detect node, which I already have open here, and we have the test object detection.py. So all that this object detect node does is it accepts images from the camera, and it will try to find objects in these images. So in our case, we're interested in finding the ball and finding the robots. So just to walk you through this, first of all, we have the initialization function for this object detection class. So here we initialize some parameters. We initialize the model that we use for object detection. In this case, it's a yellow V5 model. We set up more variables, and here we set up some publishers to publish our results, and we have some subscribers to subscribe to the images from the camera. And then we have some more stuff here. If we look at the callback function, this is where we process the images. So basically we get this message which has a type of image, and what happens is we take this message, we extract the image, we then check that the image actually contains something. If it doesn't contain anything, then we just quit, and then we wait for another image. But if it does have something in it, then number one, we process it. So we do some manipulations here to get rid of alpha channel, convert the color space from BGR to RGB, and then we, I think this is applying a horizontal kind of cutoff just to help the model ignore anything that's above horizon. At least I think that's what it's doing. Anyways, this is a bunch of pre-processing of the image before we pass the thing to the model. So the model will take the image and it will spit out some results, and the results will contain bounding boxes for various objects in the image. In our case, we detect ball and robots. So, well, at this point of time, we only detect balls, but in the future, we will add robots to the model too. But anyways, we get the results, and we go through all the different bounding boxes that were detected, and we package it into a ROS message. So we take that message and then we will send it off. So here we publish the image with the bounding boxes, and this is purely for debug purposes. We want to examine the image just to make sure that the bounding boxes look good, but in the end, it's not being used by the robot. Here we publish the actual bounding boxes. So these are just like the numerical results of what the model got from the image. And this will be used by other nodes in the system to make calculations about where the ball or the robots are on the actual field. So yeah, so this is pretty much it for for the node. Now, one way to test this node and to see what it's doing is to run a integration test. So if we scroll on the left here and go into this test integration.py, we will want to look for a test called test kick. So what this test does is it will place a robot near a ball, and it will wait for the robot to find the ball and then try to kick it. And if the robot kicks the ball into the goal, then the test passes. So this will test our computer vision part of the robot, like the object detection, and we will be able to see whether our model is working for this particular test. So in order to run this test, you can click on this triangle on the left and then just run it. So this will run, it opens up Arbis for us. You can see some of the images here. In my case, I need to enable this object detection thing. Yeah, for some reason this is not working on my computer. I think my my GPU might not have the right drivers installed at the moment. So I can't really show you what it looks like. But what you would see is the image that the robot is seeing, the actual image, kind of similar to what you see down here. And if it detected a ball, it would have drawn a rectangle around the ball. There would be like a physical rectangle around the ball, and you'll be able to see it here. Yeah, for some reason my thing is broken, so unfortunately I can't show you this. Anyways, this is a good way for you to kind of quickly debug your model, see whether it's detecting the ball properly. The other thing I wanted to show, how to get the models. So in our case, we're using a YOLO v5 model. It's a type of neural network architecture that's kind of meant to do object detection type of problem. So let me find it. So what we do is we use this function here to load the specific Ultralytics YOLO v5 model. We specify that it's a custom model, which means that we trained it ourselves, and we specify the path to that model. In our case, the path is it is inside this folder here, small model, and it's called July 14th.pt. Inside README, we have the data set that was used to train this model. So if you go into this data set, you can see that this data set contains a bunch of training images, 2,000 of them actually, and it kind of looks like this picture. There's a ball and there's like a square around the ball. We use this command right here to train it. And this is all based on this repository for YOLO v5. There's a company called Ultralytics that is developing this repository. It's a pretty good library. It walks you through how you can train your own model. If you click here, train custom data, it will tell you everything for how to do it. You gotta clone the repository, install requirements, create data set. So they mentioned that you can use RoboFlow, which I just showed you. So in RoboFlow, you can create your own data set, or you can search for other people's data set. Then number 2, you have to select the model. In our case, we're using a small model. And this is purely because we want to make sure that the computer on the robot is able to run this real time. We cannot use any bigger model, but that would need to be tested basically. So then it goes into training. Basically, make sure that you have the data set, you know where it's located, it has the right file formats. And if that's good, then you just run this one command and it should train you a model. And then once you get the model, you take that the file that it produces, and basically you either replace this file, or you have to go into Soccerbot modules, think localization, and in here we launch the ball detection node, and also we specify the model that we're trying to use. In this case, we specify the path to our July 14th.pt model. But if you train your own model, then you can just replace this with the name of your model. So yeah, that is quick overview of object detection. And yeah, that is all.